Rahim, dear students of class 11th, Assalamu alaikum. This is unit number 2, atomic structure, and today the topic is 2.1.4, that is atomic radius and ionic radius. What is atomic radius? The average distance of nucleus from outermost electronic shell is called atomic radius. Why we take average? Because the boundary of electronic cloud is not well defined, that is why we take average. Measuring units: angstrom, that is equal to 10 raised to power minus 10 meters, or picometers, which is equal to 10 raised to power minus 12 meters. Trends of atomic radius in periodic table. Number 1, it decreases from left to right. As we move from left to right in a period, the atomic radius decreases, and the reason is effective nuclear charge increases. You know that effective nuclear charge is in fact the charge of nucleus, that is equal to the number of protons. The shielding effect remains constant. Since it remains constant, therefore only the effective nuclear charge or simple nuclear charge will affect the radius of the atom. But in transition elements, the shielding effect decreases due to the filling of electrons in inner d shells or inner d orbitals. Students, here you should remember that in transition elements the shielding effect decreases as we move from left to right in a period because of addition of new electrons in the d orbital, and the d orbital's shielding effect is lesser as compared to p orbitals or s orbitals. So when the number of electrons in d orbital increases, the shielding effect also decreases. This will also affect the atomic radii of the transition elements, and as a result, because of decrease in shielding effect, the size of the atom will decrease. The atomic and ionic radii of the transition elements decrease from group 3 to group 6 due to the poor shielding offered by the small number of d electrons. From 7 to 10, they have somewhat similar atomic radii, and those placed in group 11 and 12 have larger radii. This larger radii is because of abnormal behavior of transition elements in a given period. Trend in atomic radius in periodic table, and this is part 2. It increases from top to bottom in a group. Along the group from top to bottom, the atomic radii increases. The reason is the number of shells increases as we move down the group. The number of shell and atoms increases. For example, first period will have one shell. The members of second period will have 2 shells. Third period will have 3 shells, etc. So when we go down the group, the number of shell will also increase and the size will also increase. Number 2, the shielding effect increases due to the intervening electrons. Because of the addition of new shells, the number of shell increases between the nucleus and the valence electrons, and because of the increase in number of shells, the intervening electrons number also increases, and these electrons will shield the outer electron or valence electrons, and thus the attractive force from the nucleus or electrostatic force between the nucleus and electron will decrease, and as a result the atomic size will also increase. Here is a picture which shows the increase and decrease of atomic radii along the periods as well as along the groups. You can see that when we move from left to right in a period like lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, then the atomic radii are decreasing. Similarly, when we move from top to bottom in a group like hydrogen, lithium, sodium, potassium, rubidium, and cesium on left hand side, you can see that the atomic radii increases. This is the atomic radius in picometers. Here you can see that hydrogen has 37, helium has 31, lithium 152, beryllium is 112, boron is 85, carbon 77, nitrogen is 70, oxygen is 73, then 72, and again neon has 70. As you know that neon is a noble gas, and the valence shell of noble gas is completed. The complete shell electrons will repel each other, and as a result the atomic size will increase instead of decreasing. Similarly, you can see in a group from top to bottom that hydrogen has 37, lithium 152, sodium 186, potassium 227, rubidium 248, and cesium is 265. So along the group from top to bottom, the shielding effect increases, and as a result the atomic radius also increases. Why noble gases have larger atomic radius? This is a question, and the answer is that because their valence shells are completely filled and their electrons repel each other. For example, in this diagram you can see that when we move from left to right, for example, here you can see that when we move from left to right like lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, etc., then the atomic radii are decreasing, but you can see that neon has larger atomic radius, and also you can see that all the noble gases have larger atomic radii as compared to their family members or their period members. And this is because of the two reasons. Number one, because of the completion of their valence shell, and because of the more repulsive forces between their electrons. Next is ionic radius. What is meant by ionic radius? The average distance of nucleus of an ion from outermost electron shell is called ionic radius. Why we take average? The same answer is here, because the boundary of electronic cloud is not well defined. Measuring unit, the angstrom, that is equal to 10 raised to power minus 10 meters, or picometer, that is equal to 10 raised to power minus 12 meters. These are two units used for measurement of the ionic radii. Next is trends of ionic radius in periodic table. The ionic radius of cations, that is positive ions, decreases from left to right as usual. The reason is effective nuclear charge increases. Number two, the shielding effect remains constant. Next question is why cations are positive ions? These are smaller than the parent atoms. The answer is number one, this is due to increase in the effective nuclear charge. Number two, decrease in electron repulsion. And number three, decrease in number of shells. Main point is that the effective nuclear charge increases. For example, there are 3 electrons in lithium and there are also 3 protons in lithium atom. So 3 protons will attract 3 electrons. When we remove 1 electron and make lithium positive cation, then the number of electrons remain 2 while the number of protons are 3. So the effective nuclear charge will increase. The attraction of 3 protons on electrons will also increase, and thus the size of the lithium ion will be smaller as compared to its parent atom. Similarly, decrease in electronic repulsion. Number 2 point is that the number of electron decreases and the repulsion also decreases. That is why the atomic or ionic size will also decrease. And the third point is decrease in number of shells. This is very simple. When we remove all the electrons of valence shell, that shell doesn't remain there, and the number of shells decreases by 1. Therefore, by decreasing the number of shells, the size also decreases. For example, you can see sodium has atomic radius of 186 picometers and sodium ion has 96 picometers. Here in this diagram, you can see that the size of sodium atom is larger since it has 3 shells, while the size of sodium ion is smaller because it has only 2 shells. Here another comparison. For example, lithium atom has 152 picometers size while lithium ion has only 60. Beryllium atom has 111 and beryllium plus 2 has only 31. Similarly, sodium has 186, sodium ion has 95, and magnesium atom has 160 picometers while magnesium plus 2 has 65 picometers. This is about the cationic radii. Number 2, it increases from top to bottom. All ions have the same charge, the number of shell increases. There are 2 reasons. Number 1, all ions of a group from top to bottom that have same charge. For example, alkali metals have plus 1 charge, alkaline earth metal have plus 2 charge. But the number of shell increases down the group. That is why the ionic radius also increases. Number 2, the shielding effect increases. As you know that down the group, the shielding effect increases because of intervening electrons that are present in the inner shells. And by increasing shielding effect, the size of ion will increase. Here you can see that from left to right, the size of the cation decreases up to the middle. For example, sodium ion is larger than magnesium ion and magnesium ion is larger than aluminum ion. But you can also see that the anions which carry negative charge like nitride, oxide, fluoride, etc., they have larger ionic radii as compared to their parent atoms, which will be discussed later on. Why anions or negative ions are larger than parent atoms? The answer is number 1, decrease in effective nuclear charge. Here you can see that when an electron is added in the valence shell of an atom, it converts into an anion. The number of electrons increases while the number of protons remains same. That is why the effective nuclear charge decreases and the size of the anion becomes larger as compared to its parent atom. Number 2, increase in electron-electron repulsion. You know that when an incoming electron is added in the valence shell, it is repelled by the already present electrons, and because of repulsion, the size of the radius will also increase. For example, you can see here fluorine and fluoride ion. You can see that silver ions are larger in size than the green atoms. Chlorine, that is smaller one, while chloride, it is larger one. Bromine is smaller. Bromide ion is larger. Similarly, iodine is smaller, and iodide ion is a larger one. So you can observe that the radii of anions are larger as compared to their parent atoms. Thank you for watching this video. If you like and if you understand, then please share this video with your colleagues, and also subscribe my channel if you have not yet subscribed it. Thank you very much. Thank you.